Let's take a look at this example. This time we are going to deal with three-variable Karnaugh map. Anytime you are going to see problem looking like this, it means that we are going to deal with the sum of the products, where we are going to have terms which are going to contain three variables, where C is going to be most significant bit and A is going to represent the least significant bit. Remember, we said that on the left side of the K-map, we are going to keep the most significant bit, and at the top of the K-map, we are going to keep the least significant bits. No matter what setting you are going to use, because sometimes you are going to have the horizontal way of drawing the K-map, other teachers probably are going to use the vertical. The concept is always the same. You are going to keep always most significant part of the term on the left side, and the least significant is going to be always at the top. So in this case, I'm going to have CBA, means C is going to control the left side of my K-map. That's why I'm going to write over here C. And BA is going to be at the top, BA. And because I'm dealing with SOP, sum of the products, I'm going to write BA, 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 and BA. Because I have SOP, every single variable which is above 0 is going to have negation sign over it. So I'm going to have B naught over here and A naught over here. And as I said before, C is going to control the left side of K-map. That's why I'm going to write over here C. C, and C, which is next to 0, is going to have negation sign over itself. So this is the way how you're supposed to set up the three-variable Karnaugh map. How you're supposed to set this expression into the Karnaugh map? Simply write 1 in every single cell with following numbers. So if 0, supposed to have 1. Cell 2, supposed to have also 1. Cell 3, 1, and cell 4. Anytime you will deal with three-variable Karnaugh map, you are going to group ones in groups of 1, 2, 4, and 8. You can group them horizontally, vertically, but never diagonally. How are we supposed to start solving problems like this? I always try to find the biggest groups as possible. What I mean by that, I try to group many highs as is possible at the very first moment. In this case, I can have just two groups. This is going to be one group, and this is the second group. I have two groups of two ones. Let's talk about this group first. This group is placed in one column and two rows. We have two rows and one column. First, look always at the most significant bit. I have complements. I have C naught and C. We said that we are going to ignore complements. That's why I'm going to ignore these C's and simply copy down whatever is at the top of this column. I have B naught, A naught. I'm going to write B naught, A naught. Next, I'm going to talk about this group because I finished with this one. This group is placed in one row and two columns. First, I have to look at the left side and copy down whatever I see. I have C naught. Why I'm copying C naught? Because this group is placed just in one row. I do not compare this row with anything else because this group is placed only in one row. This group is also placed in two columns. So in this case, I have to compare these two columns and choose the variable which is common for these two columns. The common variable for these two columns is simply b. That's why I'm going to write over here b. I finished with the simplification. Check if you can factorize something or change to the exclusive OR gates, but at this moment we cannot do anything with it. So I'm going to simply implement it. This is nothing else, just two AND gates, and I have input B connected to the inverter, and I have input A also connected to the inverter, and I have another AND gate with input C connected to the inverter, and I have input B. Remember that these B's are always connected. I do not connect them on the board, but if you are going to look at the electronics diagrams, anytime you see B and B means there is always physical connection between these two points. And everything is ORed together. This is my output. So these are the solutions to my problem. Let's take a look at this example. We have ones in following cells: cell 0, cell 3, cell 4, and cell 5. Next, we're supposed to group these ones. I'm going to have one group over here, second group over here, and the third group over here. Remember, I can make the groups of 1, 2, 4, and 8 for 3-variable Karnaugh map. Let me look at the first group. I'm going to have on the left side complements, because this group is placed in 2 rows, and then anytime I have 2 rows, I have to compare the variables on the left side of the rows, and I have complements. That's why I'm going to ignore them. And because this group is placed in one column, I have to copy everything, whatever is at the top of this column. That's why I'm going to write B naught, A naught. Next, I'm supposed to look at the second group. The second group is placed in 2 columns and 1 row. Remember, anytime we have 1 row, don't think too long. Copy down whatever is on the side of the row. So I have plus C. And the common variable for these 2 columns is B naught. Why I'm looking at these 2 columns? Because my group is placed in 2 columns. So if B naught and B naught is the common variable. We said complements we will always ignore. That's why I'm going to write over here B naught. The third group is this one. So this group is placed in 1 row and 1 column. Simply you copy down everything whatever is at the side of the row and everything whatever is at the top of the column, because we have just 1, 1. So I have plus, and I have C naught B A. Remember, after using Karnaugh map, you cannot use Boolean algebra. You can do some factoring and conversion to the exclusive gates, but never use Boolean algebra. So, what we can do over here? Please notice that we have B naught and B naught over here. We can factorize B naught. I have B naught, And inside of the parentheses, I'm going to have A naught or C plus, I'm going to rearrange this term a little bit. I'm going to write B over here and C naught and A. Please notice that these two terms are complements. I'm going to call this term Q, and this one I'm going to call Q naught because they are complements. And I'm going to rewrite my expression as B naught Q or B Q naught. As you can see, this is nothing else, just exclusive OR. So I'm going to rewrite this as B exclusive OR Q, where B exclusive OR Q is equal A naught or C. I'm going to write A naught or C instead of Q. Now I can implement this function. This is nothing else, just the OR gate with inverter. Is exclusively OR with B. And these are the solutions to my problem.